Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on IoT architecture and protocols. And the topic which I'm going to discuss today here is the modified OSI model for IoT machine-to-machine system. So the main feature of this type of modified IoT OSI model is the layer merging here. The 7 layer is merged, so that merging will reduce the complexity. So modified in the sense the 7 layer protocol model has been merged and it is reduced. So that will reduce the complexity. It supports low power devices. It enables real time communication, and also it would integrate with cloud and analytics and adds business intelligence layer as well. So before discussing about these type of layers of this modified IoT OSI model, let us first discuss about the empathy part of the four challenges faced in the IoT environment and how the end users are giving the feedback and how it is analyzed. So the first and foremost thing is the resource constraints. So IoT devices, they have limited processing power, memory, and storage. So this makes it difficult to implement the complex OSI layer. So to reduce that, we merged the layers. And the next parameter is power consumption. So many IoT devices are battery powered. So that requires the protocols and architecture to minimize the energy usage. And the main important parameter is the bandwidth, that is low bandwidth. So the wireless IoT networks, so they frequently operate with very low bandwidth. So that is very challenging for this protocol stacks to generate the layers. So this is the empathy part of this IoT environment. So the problem statement here is we define to address these limitations. We reframe the OSI model. So the limitation of traditional OSI model is being changed as modified OSI model. So that is the streamlined architecture for IoT. So this will propose only few layers. So where it has been integrated for specifically for real-time applications. So the 3 layer architecture and the 5 layer architecture are proposed. So here let us discuss about the 5 layer architecture. So the 3 layer architecture is we consider it is all other or merged together as perception, network and application layer. And the 5 layer is here the perception, transport, processing, application and business layer. So this is how the modified OSI model is being defined. So now let us discuss about the 6 layer modified OSI model for IoT application. So here the first one is let us discuss about the physical layer here. We combine the physical and data link layer. So the main function is that it handles the physical devices and hardware transmission. It converts the real world signals into the electrical signals. So here the IoT role, talking about the role of IoT is it includes sensors and activators, which is mainly responsible for data generation. For example, humidity sensor, temperature sensor, RFID tags, etc. So in data link layer, the function is that it ensures the node-to-node communication, error detection and correction, and the framing and MAC addressing. So the protocols like IEEE standard protocols, IEEE 802.15.4, the ZigBee, Bluetooth, etc. So all these are used in this data link layer. The next is the network layer here. So that is going to handle the routing and addressing. It transfers the data across the networks. And the IoT role here is it will enable the communication between the devices and cloud. Also, it supports the IP-based communication. And the protocols here are, you can talk about the 6LoWPAN, IP version 6, etc. And then the next is the transport layer. Here. So the transport layer will provide end-to-end communication, ensures data delivery reliability, and also this is a lightweight transport mechanism for constrained devices, which is mainly useful for IoT application. And the protocols under this layer are TCP and UDP. And then the next is the session and presentation. Here we combine together as application support. So that will manage and establish the session. It is mainly for synchronization of the communication. So maintains the connection between IoT devices and the servers. So for example, we can talk about the session handling in MQTT communication. So the presentation layer would go with the encryption, data formatting, compression techniques, etc. So the IoT role here would be it ensures the interoperability between the devices. And finally, the application layer, it is acting as the interface between the user and the system, and it provides application specific services. So the protocols here are, we can talk about the IoT protocol like MQTT, CoAP, HTTP, etc. So the applications are smart home, healthcare monitoring, and smart cities. So as we have discussed each and every layer, so it is clearly given application layer it is the last layer where it provides the direct interface between the user and the server. And the processing layer process all the data. Network layer, it enables the communication. And the perception layer, it is for the sensors and activators, physical devices. So the testing here for real world IoT use cases, we can validate the efficacy here by applying it to the real world IoT use cases. So the examples are, as we have discussed, smart home automation, industrial IoT monitoring, where predictive maintenance are the major role playing here. So this is the application of the IoT, that is with the help of this modified OSI model, various use cases are there for IoT applications. So let us sum up. So this is the overall mind map of this modified layer. So we have discussed about the challenges what are involved in IoT applications. So how to address those challenges? We have modified the architectures. We have reduced the complexity, and how the layered architecture, 3-layer, 5-layer, and 6-layer model. So we have discussed about each and every model and the real world use cases related with the smart home and industrial IoT. So today's assessment is which layer is a typical IoT model which deals with physical sensors. So it is our obviously the perception layer. In context of IoT and MTM, what is the primary role of application layer? So that provides the user specific services like monitoring and control. Thank you.